Welcome dear students. In this lecture we are going to talk about the polar and non-polar molecules. My dear students, a non-polar molecule is the one in which either all bonds they are non-polar or the bonds are polar but they are directed in a way that the center of the positive and negative charges is same. And a polar molecule is the one which has one or more polar bonds and it has separate centers of the positive and negative charges. So a polar molecule has one or more polar bonds and its bonds are directed in such a way that the centers for the positive and negative charges they are different. Now let us see some examples. For example, we have a molecule of carbon dioxide. Now, dear students, in this molecule, you can see that because of the difference of electron activity between carbon and oxygen, the two bonds, they will be polar bonds, delta positive and they are delta negative. So, the first condition for a molecule to be polar, that is satisfied here because it has two polar bonds. Now, the second one is that the separate centers of positive and negative charges. My dear students, the center of both these negative charges, this one will be this carbon because the carbon is the center of both the negative charges. And even the center for this positive charge, that will also be carbon. So in this case, the bonds are directed in such a way that the centers of the negative charges and center of the positive charge that is same. When the two centers they are same, then this molecule that will be considered as the non-polar molecule. Similarly, let us see another example in which we have carbon tetrachloride. Now again, due to the difference of electron activity between carbon and chlorine, all four bonds they are polar bonds. Chlorine being more electronegative will get delta negative charge and carbon being less electronegative will get delta positive charge. Now my dear students, the first condition is again satisfied. It has four polar bonds. Now the second condition, the center of positive charge, that is obviously this carbon, and you can see that the center of all these four negative charges, it is also this carbon. So again, the bonds are directed in such a way that the center of both positive and negative charges is same. So that will also be considered as a non-polar molecule. For any molecule to be polar, these two conditions should be simultaneously fulfilled. Now let us see another example in which we will talk about water. Now, my dear students, in case of water, the oxygen is delta negative and both hydrogen, they are less electronegative, they will be delta positive. So, the first condition is fulfilled because it has two polar bonds. Now, the center for the negative charge, that will be this oxygen, and the center of these two positive, that will lie somewhere like this. So the center of negative charge is oxygen and the center of these positive charges that will be in between these two hydrogen atoms. It means that the bonds are directed in such a way that the negative center and the center of positive charges they are different from each other. So this molecule will be a polar molecule because both conditions are satisfied here. It will be a polar molecule. So for any molecule to be polar, these two conditions must be fulfilled simultaneously. If any of these two conditions is not fulfilled, then that molecule will be called as the non-polar molecules. My dear students, there are two concepts of the polarity. Listen very carefully. The first one is polarity of bonds. Dear students, the polarity of bonds is decided only by the difference of electronegativity. If the difference of electronegativities is greater than 0.4, From 0 to 0.4, the bonds are considered as non-polar. But if the difference of electronegativisty between two bonded atoms is greater than 0.4, then that bond will be called as the polar bond. And if the difference of electronegativity lies somewhere between 0 to 0.4, then that bond will be called as the non-polar bond. So what I want to say is that the polarity of a bond is totally related to the difference of electronegativity of the bonded atoms. But as far as the polarity of a molecule is concerned, that is different, because a molecule, even though having polar bonds, can be non-polar, just like CO2 and CCl4, in the case where the positive and negative charges, they have same centers. So the polarity of a molecule, that is decided by, because a polar molecule acts as a tiny magnet, so it has dipole moment. The polarity of a molecule is decided by dipole moment, that is the product of the charges and the distance between the charges. If the dipole moment is zero, and dipole moment is zero when there are no polar bonds in the molecule, or if the molecule has polar bonds, then the bonds are directed in a way that the positive and negative centers or charges, they have same centers. So if the any one of these two conditions is not fulfilled, or even the two are not fulfilled, then the dipole moment will be zero, just like in case of CO2 and in case of carbon tetrachloride. The dipole moment is zero. So even though they have polar bonds, overall the molecules, they will be non-polar. So all molecules with zero dipole moment will be considered as non-polar. But if a molecule fulfills both these conditions, then that will be considered as the polar molecule, and the polar molecules, they have dipole moment greater than zero. That molecule, they are considered as the polar molecules. And polar molecules have these two conditions fulfilled, just like water. The dipole moment of water, that is 1.85 dBi. DBi is a non-SI unit of the dipole moment. So now let us conclude the lecture. The polarity of bonds is decided by just electronegativity difference. If the electronegativity difference is more than 0.4, the bond is polar. Is from 0 to 0.4, the bond is non-polar. But the polarity of molecule, that is not related to just the electronegativity difference. It has two conditions. There must be polar bonds, and the bonds should be directed in a way that there must be different centers for the positive and negative charges. And the polarity of molecule is decided by the dipole moment. I have already delivered a detailed lecture about the dipole moment. If you want to watch that lecture, the link will be given in the description of this video. If the dipole moment is zero, molecule is non-polar, no matter whether it has polar bonds or non-polar bonds. But if the dipole moment is not equal to zero, then that molecule will be considered as the polar molecule. So the deciding factor in the polarity of molecules is the dipole moment. It was all about the polar and non-polar molecules.